Hello and good evening, guys. I'm back again with another video, and in this one I'm going to talk about the feature selection technique, which is called measure information. At first, I'm going to give you some explanation and insight about what mutual information is, and then I'm going to write a Python script of it. If you just want to see the Python script, skip ahead because you can find the explanation of this technique in multiple resources, and they definitely explain this far way better than me. And even you can ask AI, why not? So in water resources discipline, we have multiple variables such as stream flow, soil moisture, air temperature, and etc. And imagine that you want to predict one of them. Let's assume you want to predict stream flow, and you want to develop a machine learning model in order to do this task. So you cannot just add all those features into your model as an input and get that prediction out of it, because it has a huge computational cost, it requires a great system, and it takes a lot of time. And aside from this, it has a huge amount of complexity and uncertainty in it, and the results might not be as solid and significant as they should be. So in order to solve this issue, we have to just find those variables that have relationship with our target variable. So how we can achieve this goal? Well, and the solution to it is using feature selection techniques. One of them is mutual information. Mutual information is an information theoretic solution, which you can know more about this in channel 9048. Mutual information, it measures how much a random variable contains information about target variable. So we assume that you want to predict your stream flow. So you use EMA, emission information, in order to see how much precipitation, soil moisture, and other variables contain information about your target variable. This method uses Kalbach-Leibler divergence, which is a technique that it calculates the distance between two probability distributions. Between the joint distribution and the product of marginals, the marginal is used since if variables were independent, their joint distribution and marginal distribution would have been equal. So you can see the equations of mutual information for both discrete variables and continuous variables over here, and you can see the entropy form over here. And I've put an example over here about tossing a coin for 2 times, and you can add it in these equations and do the math for yourself to understand it better. But I'm going to explain some conditions of mutual information as well. So mutual information can never be negative, so the higher it gets, the, the better the relationship between that feature and your target variable is. So the information that x reveals about y is exactly the same as the information y reveals about x. So the information that precipitation reveals about a stream flow is the same as a stream flow reveals about precipitation. So if mutual information is equal to 0, it guarantees true independence. So imagine that mutual information between your stream flow and precipitation is 0, so it means that these two variables are independent and you can just not use it. So the mutual information of a variable with itself equals its entropy, and if you want to just know more about entropy, go ahead and see this channel 9048 and you can understand it better. But the explanation of this entropy concept is out of the aim of this video. So the next condition is if z is derived from y, then z cannot contain more information about x than y does. So in simple terms, processing can only lose information, never create it. So at the best thing, as the most optimum thing, you just don't lose information, that's it. So this is kind of a deal that is more related to neural networks, and this is the end. The last condition is for more than two variables, as you can see over here. There's the equation and etc. So for Python script, I'm going to use the scikit-learn library, which it has two type of mutual information. One of them is classification and the other is regression. The regression form uses this equation for continuous variables, and the classification form uses the equation for discrete variables. So as you can see, you can call and import them in, in respect to your variables, whether they are continuous or they are discrete. So this was the explanation part, and now I'm going to write the Python script. So now I'm going to write the Python script of mutual information. So first I'm going to import my libraries, which I'm going to import pandas in order to handle my data. Import pandas, pandas as pd. Then I'm going to import matplotlib, import cburn as an s. I'm going to import matplotlib as plot, and I'm going to import sklearn here feature selection. Sorry, I'm going to import from features from sklearn. So yeah, import mutual information regression. You can obviously see the explanation of this over there. So at first section, I'm going to import my data. Section 1, adding date. So I'm going to write my CSV over here. I have my data pd read CSV. I have my data over here. Then I'm going to call my target variable and my features. So in here I have my stream flow as my target variable or discharge, and then for my features I have about some of them. There's actually too many, but I'm going to call them. You can just skip it a little ahead. There's just too many variables and I forgot to write that down. Average temperature, I'm going to use minimum temperature, I'm going to use maximum temperature, and I'm going to use somewhere equivalent of my data. These data are actually solid and they belong to Upper Colorado River Basin. So, and I'm going to write the results in a dictionary right here. I'm going to enter a dictionary one. Okay. So now it's time to add my mutual information. For section 2, I'm going to add mutual information and calculate it for my data. So first I'm going to write mutual information score, which is mutual info regression for my features target, and I have to add this random state. You just gotta put none over here, because whether if you add a number, a value for reproducibility or none, it doesn't make any difference since you are not training or testing your mutual information technique. So, and then I'm going to save the results in my dictionary that I have created in the name of final score. So they're going to be a p pandas series, which contains mi score, mutual information score, with its index is equal to features columns. So now, and then I'm going to print it down over here. Again, I'm going to write pd.date in the data frame, save it, and finally print it. Results was the whole measure information thing, but I'm not, if I am going to do a research or anything else, I need something shiny and some good plots for my research or study. So I'm going to need a heat map. I'm going to use a heat map in order to show you my results of measure information. I'm going to use plot figure over here. My fixed size is going to be equal to, okay, so here there's a trick. I'm going to use 8 inches as my width, and then I'm going to add len of my feature columns here. Features columns. Because if you add just a simple value for this section, you might see compact results in your plot. So it's better to have this, so it's kind of optimum. No matter how much variables you add, in proportion to that number of your features, it will create the plot. So it's easy, this one. So I'm going to import the heat map from my dear Seaborn. First, it's going to be MI. I'm going to need my annotation. I'm going to need my true values on my plot. I'm going to need some digits over here, which I'm going to need four is better, yeah. Then I'm going to add my color over here, Y, O, R, D. Then I'm going to add line width equal to 0.5, and then for my legends, label is going to equal to my MIS score. So this was it, and then I'm going to add some plot title over here. Plot dot title is going to be, I'm just gonna write mutual information, but in the final script I'm going to add some shine to it. Never mind. So the font size is going to be about, font size is going to be about 13, and font weight is going to be bold. So, and then I'm gonna print out my plot over here. Then I'm going to save it, plot.save figure, in the name of MI. For better resolution, you can just add more to this section. Sorry. You can just add more to this value, just for better quality or resolution in order to put it in your paper research or anything. So that was it. So I'm going to run my measure information here. Run. Come on. Why does not run? Sorry for the delay, guys. I just mistyped this label over here, and I'm going to just show you the final results. Let me just run it one more time. And here it is, and as you can see, the higher my mutual information score, the more relationship with my target variable, which is streamflow. And as you can see, the results might somehow look not okay or rational, but believe me, I have run with other techniques and they have shown the similar results. Also, the thing I want to mention in this video, it might not really relate, but I'm just going to add it, that this SWE or snow water equivalent, it might not actually show it in that exactly t time. Like for example, I have using each time for itself. So if I add lag time, because you cannot see the results of SWE in within the same month to Streamflow, since my event data is for a basin which is snow dominant. But this was the result, and this was the code, and sorry for some delay in between. I hope it was a good tutorial for you about how we can use Meteor information. I hope you use it well in your research or reports or your studies or anything. I hope you find it useful, and in the next videos I'm going to explain some more of these feature selection techniques. I hope you all have a great week, and again find this video useful.